So hopefully you've determined the pattern, what's happened between the exponents. But if you haven't, what's happened between the exponents is they're being, this time, subtracted. So 8 to the 3 minus 5 gives me 8 to the negative 2. 6 to the 8 minus 2 gives me 6 to the 6th. In the third problem, 7 to the exponent of 11 minus 4 gives me 7 to the 7th. In the fourth problem, 5 to the 3 minus 5 gives me 5 to the negative 2. And then the last one, x to the 3 minus 3 gives me x to the 0. So what's happening here is the exponents are being subtracted. So if you would continue with the next 4 problems, and again using the rule here, so we don't want to do the expanded form here, what would be the final answer? We like the exponents or the base to be written in the numerator, and if the base happens to be, if the exponent happens to be negative after you're done using the rule, then they'd like you to rewrite it and go back to the previous problem. They'd like you to rewrite it so that the exponent is positive. Turn the video back on when you're done with the 4 problems. All right, so this problem here, we have 4 minus 4, so it's 5 to the 0 power. This one here, I subtract the exponents, I get 7 to the 0 power. This one here, if I subtract the 2 exponents, I get 7 to the 5th. And this, if I subtract the 2 exponents, I get 9 to the negative 2. Because the exponent is negative, as we provided the previous problems, that means that to make the exponent positive, the 9 to the 2nd power would be in the denominator. Now, before we look at the 2 rules that come out of this, what I'd like you to do is I'd like you to put 5 to the 0 and 7 to the 0 in your calculator to see what that answer is. And there's also the problem above it, 8 to the 0. So if you do those 3 problems, because there's actually another rule that's happening here when you get an exponent of 0. When you have the answers, turn the video back on. So hopefully you found, when putting these into your calculator, that you always get the answer of 1. So we have a quotient rule, because we have fractions here, so we have a quotient rule, and we have a 0 rule that's going on here. So if you copy down the quotient property for exponents, you copy down the 0 exponent rule as shown on the screen, and then if you would go ahead and finish off the rules. When you're done, turn the video back on. So the first one, hopefully you wrote down x to the m minus n, because under the quotient or the fraction, we subtract the exponents. In the second one, we're doing the same thing. We're subtracting the exponents, and what we end up with is x to the 0, because we're subtracting the same 2 numbers. And anytime we have x to the 0, it's always 1 as long as x doesn't equal 0. So if you put in 0 to the 0 power in your calculator, what you'll end up with is an error. All right, so before we move on to any other problems, we're going to continue with our discussion about the negative to positive exponents. So anytime you see a negative exponent, and you're being asked to write as a positive exponent, you're going to take the base of the exponent and move it into, think of it as a fraction. This is in the numerator where the exponent's negative. So therefore, to make the exponent positive, that means that the 3 to the 2nd power will move into the denominator. In the second problem here, the 3 actually has a positive exponent of 1, but the x has a negative exponent. Since the 3 already has a positive exponent, it stays in the numerator, but because the x has a negative exponent, it goes to the denominator. So this one here, if I simplify so everything has a positive exponent, it would be 3 over x to the 5th. In the third problem, since the 4 has a negative exponent in the numerator, that means that I move the 4 to the 5th to the denominator, the exponent becomes positive. Same thing with the second one here. The x to the negative 3 is negative in the denominator, so that means if I move it into the numerator, the exponent becomes a positive 3. So why don't you go ahead and take a look at the last two problems and see if you can figure out those answers based on the discussion for the first 4. Turn the video back on when you're finished. So the first problem, the x squared has a positive exponent. So it's going to stay in the numerator, and then the y to the 8th actually will get moved up into the numerator because it has a negative exponent in the denominator, which means in the numerator it's positive. And the last one, the only one that's staying where it's at, is the m, because the exponent's already positive. So the x will get moved into the denominator to turn the exponent into a positive 5. The y gets moved into the denominator for the same reason, and then the z gets moved up into the numerator to change the exponent from a negative to a positive. These are not addition problems. When you move these expressions into the numerator and denominator, they are multiplication problems. So this rule only works under multiplication. So we have four. Basically, we have 4 rules at this point. Let me back up and let's talk about the 4 rules we've talked about, and then we're going to look at some problems from the worksheet. So what we have is the product rule. That was the first rule. So x to the m times x to the n is equal to x to the m plus n. We had a power rule, which we have x to the m with a parenthesis of n, and so we did the exponents here as we multiply them. We have a quotient rule, and that was our fraction, x to the m over x to the n. And what we did with the exponents here is we subtracted them. So we have a rule that involves addition of the exponents, a rule that involves multiplication, and a rule that involves subtraction. We do not have a rule that we divide the exponents. We either add them, subtract them, or multiply them. And then the last rule is the 0 rule. And this is when the exponents and the base are the same in the numerator and denominator. So when I subtract the exponents, I end up with x to the 0. And x to the 0 is always 1 as long as x doesn't equal 0. So these are our 4 rules. So again, there's 8 altogether. So I thought we would do half of them today and then the rest of them on our next class. So we're going to go back to, actually we're going to go to the worksheet, and the handout that's given to you has like over 60 problems. You're assigned 1 through 59 odd, and I thought I would do some of the even problems with you. So you go ahead and, again, with your paper, write down the problems that are shown on the screen, 12, 16, 20, and 22. And I'd like you to take a look at the problems and try to do as many of the problems as you can based on the 4 rules that we've discussed today. And when you're finished, turn the video back on. So the first one is the product rule, because we have the bases being multiplied together. So what we do is we take the 2 exponents and we add them. So what we end up with here is 4 to the negative 5. And one of the things I'd like you to do, or encourage you to do, is anytime the exponent ends up being negative, is to please rewrite it so the exponent is positive. So you go ahead and do that at this time before I move on to problem 16. So we talked about that this would be over 1, so that to make the exponent positive, 5, before the 5th power would move into the denominator. In the second problem, we have 4 and 3 different bases, so we don't have a rule for that because they're different bases. So your answer key would look like for this problem is it actually would take the 4 and the 3 and multiply them together to get a single answer of 12. The exponent on the second m is a 1, so it's going to be negative 3 plus 1. So the final answer would be 12 times m to the negative 2. Because the exponent is negative on the end, take a moment, rewrite it so the exponent on the end would be positive. Turn the video back on when you're done. So the 12 has an exponent of 1, so it's going to stay in the numerator. But because the exponent on the m is negative, then we would move the m squared to the denominator, and again the exponent would become positive. Problem 20, a lot like 16, we have two numbers that have different bases, 4 and 3, so we just simply multiply those together. And then with the x, we would take the exponents, this is the product rule, and we would add the exponents together. So we have negative 4 plus 2 plus 2. And that would give us 12 to the exponent of 0. Based on our 0 exponent rule, x to the 0, as long as x is not 0, would become 1. So the final answer for this problem here is just simply 12. So anytime you see x to the 0, 5 to the 0, 16 to the 0, we're going to replace that with the value of 1 to continue simplifying. In the last problem, this is a product rule. So we take the two exponents and we multiply them together. So the final answer here is 2 to the 12th. So in this set of problems, again, we're going to be using those same rules. So if you copy down these 4 problems and then use the rules we've talked about, go back and look at the previous problems if you need to. And then when you're finished with them, turn the video back on. Now, problem 26, you may find after you do 26 you want to go back and look at 36, 38, and 40 and change something, which is fine. But in problem 36, the exponent on the 4 is a 1. So the product rule says when you have parentheses with an exponent inside, outside, what we do is we multiply the 2 to the exponent on the inside. Because we have two exponents, the one on the 4 and the one on the p, the 2 gets multiplied not only to the 1, but also the 2 gets multiplied to the 3. So the final answer here would be 4 squared times p to the 6th. So based on what I just talked about, if you didn't complete the exponent part of it correctly on the number 4, and you want to redo your 36 and 38, go ahead and do that. Turn the video back on when you're done. So in 36, it becomes 2 to the first. This is the multiplication rule, so we're going to multiply the 3 to the 1, and we're going to multiply the 3 to the 3. So the final answer here is 2 to the 3rd times x to the 9th. This one here we're multiplying the exponent of 4 to the 1 for the 4, and to the negative 4 on the k. So we end up with this 4 to the 4th times k to the negative 16th. Because we have a negative exponent, the 4 to the 4 stays in the numerator. This would all be over 1. But the k would actually move to the denominator to change the exponent from a negative to a positive. The last one is a quotient. The exponent of the 3 is a 1, so it becomes 3 to the 1 minus negative 4. And 1 minus negative 4 is actually 3 to the 5th. Make sure you don't write down 1 minus 4. You're subtracting the exponents, and the second number is a negative 4. So that actually makes it really an addition problem of 1 plus 4. So for the last one, we have 3 more problems, 48, 54, and 56. Again, we're running out of time in terms of the video, so I'm going to have you write down these problems and then turn the video back on, and I'll have the problems completed, and I'll go through them quickly with you. And these are our last 3 problems for discussion for today. So in problem 48, the 3 itself we're not doing anything with because there's only one single 3. You can't simplify it. There's no other 3 to subtract exponents from. So 3 just stays in the denominator. The x's, there's 2 of them, so it's our quotient where we're going to subtract the 2 exponents, and 3 minus 2 is 1. So this is going to be x to the first power over 3, or just simply x over 3. In problem 54, we subtract the 2 exponents, so negative 2 minus 2, we get 4 to the negative 4. Because the exponent's negative, we move it into the denominator, so it becomes 1 over x to the 4. In 56, the 3 and the 4, we don't do anything with, so we subtract the exponents, and our final answer is